Hi, and welcome to the video on generative AI with Snap. Today I'd like to show you how to program a chatbot. And I'm going to show you how to program a version of the original classical chatbot called Eliza, which was developed by Joe Weizenbaum 1964 to 1967 at MIT. Eliza uses a linguistic model of pattern matching and substitution to mimic not really so much artificial intelligence as artificial empathy. It mimics an active listener by impersonating something like a doctor, like a psychotherapist, that takes what the user tells it, asks, and plows it back to the user, swapping the standpoint and exchanging some words for others to give the impression of being empathetic and listening actively. So we're going to build this in Snap. In Snap, we actually don't need a sprite. We can do it all on the stage. And the cool thing about Eliza was that it really is sort of its own programming language, in that the program itself is contained in a bunch of rules. So here's a bunch of rules I got. So these rules are a table where the first column is a pattern. And so when the user writes something, Eliza checks which pattern this matches and then takes any of these responses by switching, by kind of remembering what the user told and what the user told it, and by sort of asking this back to the user. And it does so by using a wildcard match that takes parts of what the user says, assigns it to a variable internally, takes what's in that variable and swaps the viewpoint of that, and then asks the same thing back to the user, formulated slightly differently. So in order to kind of do this, the central core point of Eliza is the pattern matching, the fuzzy pattern matching algorithm. So let's actually try to do this. I'm going to make a new block. It's going to be a predicate, and it's going to find out whether a pattern matches a sentence. And pattern is going to be an input as a sentence. And now if we want to work with words in patterns and sentences, the best thing to do this in Snap is to load a new library. We've got a library that's called Words and Sentences Library, and that's perfect for working with words and sentences. There's one underneath there that's called Just Words. It has fewer blocks, and for the purpose of doing just Eliza, it's enough. So I'm going to use this. You can use either that you like. Now I have 4 more blocks. The first word of this is fine is this. All but the first word of this is fine is fine. So I can look at the first word of the pattern. I can look at the first word of the sentence. And I can, first word of the sentence. And I can compare them. I can test whether they're equals. If they're equal, I can also then look at all but the first word of the pattern and compare it with all but the first word of sentence. And the comparison here should be the match again. So this is so if both of these are the same, if both of these are true, you can say, if the first word is equals and the rest also matches, then we're fine. But since this is a recursive definition of the match, at one point, we're going to hit the end of one or the other. So we need to define a base case. base case means the conditional. So if the pattern is empty, both can still match if also the sentence is empty. Otherwise, we need to go through the words and compare them. So I'm going to make a bunch of test cases to try this. So let's see. I'm going to say the quick brown fox jumps over the lazy dog. And I want to compare this with the same thing. I want to compare the quick brown fox jumps over the lazy dog with the quick brown fox let me say runs over the lazy dog. I'm expecting those not to match. And then I want to model some of these wildcard things. So let me say, instead of the quick brown fox, anything, if it's the anything, is the asterisk, and I want to assign this to the variable x, jumps over the, and then again, this could be anything. So it's another asterisk, and I want to assign this to the variable y. I want to find out whether this pattern matches this, and I would expect those to match. Let's make another case where I'm saying it doesn't jump, but it runs, and I would expect those not to match. So right now, if I click on this, they don't match because I didn't implement the wildcard match yet. Those are identical, so they do match. Those are not identical, they don't match. So the next thing I need to do is I want this one also to match. So I need to make another block, which is the wildcard match. So I'm going to make a block. It's going to be another predicate. It's going to be called wildcard pattern matches a sentence. And again, the pattern is going to be an input, as is the sentence. And I want to use this whenever I come across the asterisk. So if, the first word of the pattern equals the asterisk, then I want to do a wildcard search. So this is if the first word of the pattern equals the asterisk. I want to do a wildcard comparison of the pattern and the sentence. So I can now reformulate my match block with this condition. Let's try this. So now these still match. This, we know it doesn't match. Here's a wildcard. We should be getting nothing right now. And we are getting nothing. And also here we're not getting anything. So now let's actually, we know that this works. Let's work on the wildcard part. And the wildcard part, I'm going to define a bunch of cases to find out whether they match. Now the first case is, let's look at one of these wildcard patterns. It starts with an asterisk and a variable, and then the rest. So we want to check whether the rest matches. Now the rest is all but the first word of a pattern, and then again all but the first word. Then we're getting the rest. So if the rest matches the sentence, then we know they match. So we can report true here. If they don't match, we need to go through the words, and at one point we're going to hit the base case, and the base case is going to be if the sentence is empty. We're at the end, we didn't find any match, so we know they don't. So now we can report false. And then there's the case where the pattern matches all but the first word of the sentence. And if that is the case, then it's a variable declaration, but then we know they also match. So we can say this matches. And if none of these cases are there, we know they don't match. Let's actually try this. So let's look at this one. They should match, and it does match. This one should not match because we exchanged this jump word against run, and it doesn't match. Okay, so here's fuzzy comparison, fuzzy match implemented in Snap. Now what we also need to do is we want to assign these variables. So I'm going to hide the rules in the viewpoint. And to do a variable assignment, let's make another variable. And those are called bindings. I'm going to initialize the bindings to new list. So here are my bindings. They're a new list. It's an empty list. And now whenever I'm coming across one of these variable declarations, I want to bind them. So let's make a new block. A new block. It's going to be a command block. It's going to be bind key to value. Okay. And key is going to be an input. And value is going to be an input. And the way what we want to do with this bind block is here, in this case, where the pattern matches all but the first word, we want to bind the first word of the pattern, we want to bind it to the first word of all but the first word of the sentence. Actually, it's the other way around. We want to bind the first word of all but the first word of the pattern to the first word of the sentence. And the same thing we want to do in this other true case here, except that we don't have a sentence. So we can leave this empty. So let's actually fill this with life. So to bind something in Snap, we can use the replace or the insert blocks along with a list. And so the list that we made for this is the bindings list. So we use the bindings, and we want to insert the key. We want to insert the value at the key of the bindings. Let's try this now. I'm going to click on the asterisk X, jumps over the asterisk Y. And I'm clicking on this. And what I'm seeing here is, yes, there's a binding. We can right click here and look at this as a table view. Then it looks more like a dictionary. And we can see the variable X has been associated with quick, and the variable Y has been associated with lazy. That's already kind of neat, but I actually want to associate it not just with the last word, but with all the words that come. So in order to do this, we not just want to look at the value, but we also want to look what's already in there. So we want to get the item key of the bindings, turn these into a sentence, and prepend it with the value. Let's look at this. And again, before we do the match, we always need to remove what's in the bindings. Otherwise, it's going to keep adding to it. So I'm going to delete all of the bindings. And now let's click on this again. And we see, okay, now we're getting all the bindings. We're getting everything that, matches assigned to these variables. Great. So bindings works. And the wildcard fuzzy match also works. So now when we look at the what Eliza does, it also swapped the viewpoint when talking back to the user. So the user would say something that would contain the word I, and then we want to replace this with you. So in order to do this, we can, for example, look at the viewpoint. We can ask the viewpoint, what is at I is you. What is, for example, as was is were. But if we asked it something that's not in the dictionary, like, for example, frob, there's nothing there. But we still want to use that word. So in order to still use that word, we're going to make a new block. It's going to be a reporter, and it's going to say, look up key in dictionary, and key is going to be an input, as is dictionary. We can specify dictionary to be a list. And how this works is we want to report the key, not in viewpoint, but in the dictionary. But if the key doesn't exist in the dictionary, we just want to use the key. So we're going to make a variable that's going to be called the value. We're going to assign the value to whatever's in the dictionary. And then we're going to return if that value is empty. We're just going to return whatever got passed into it. Otherwise, we're going to return the value. Let's try this. So here's the lookup function. We're going to look up something in the viewpoints. So if I look up me in the viewpoint, I get you. If I look up Hans in the viewpoint, I'm getting Hans. Okay, so this works. So now what we can do is, in the bind block, instead of, making a sentence with the value, we can take whichever value gets passed in and swap it by looking up the value in the viewpoint. And the other thing we want to do is that when we find something, we again want to replace everything that we've now saved in this dictionary. We again want to substitute all of this. So we're going to make another final block that is going to be called fill in sentence. And sentence is the only input. And in this case, we're going to take all the words. We're going to take the first word of the sentence. We're going to look it up in the bindings, whether it's a Y or an X. We're going to turn it into a sentence along with, all but the first word of the sentence filled in. So this is another recursive function. And since it's recursive, we again need to define the base case. We could say, if the sentence is empty, I'm just going to return an empty text. Otherwise, we're going to do the fill in. And with these 5 blocks that we've made, we should now be able to do a rendition of the original Eliza. So I don't need all these test things anymore. I can delete all of the bindings. I don't need the viewpoints. I can hide these. I can hide the bindings. So what I want to do is I want to ask the user something, and I want to base it on the answer. So we're taking whatever the user says, and we want to find the first item in the rules, in these rules, the first item in the rules that match what the user said, kind of in which the first item matches it. So the first column. So we're going to find out the first one where the first item matches the answer. Let's actually try this. If I click on this, it's user didn't answer anything. So the match where they didn't yet say anything is this one. Hello. It says hello. And so now there are 2 possible things. You could say hello or what's on your mind. So we want to take all but the first items of this, because the first is the pattern. So what's left is hello or what's on your mind. And out of any possible answers, we're just going to take a random one. So there's a random one, what's on your mind or hello. And there could be other things in there. There could be X and Y in there. So we want to fill these in, whatever is in bindings. And this is what we're going to ask back to the user. So let's actually try this. So all the times we want to set it to a new list. And now we can try this out. We can say, what's on your mind? And I could say, I wish you Merry Christmas. And the next question would be, why would you if I a Merry Christmas? Okay, kind of a funny sentence. So now let's actually turn this into something cool. So when the green flag is clicked, I'm first going to reset the answer. And then I want to keep repeating this until some stop condition is met. So let's actually repeat this until whatever the user answers is, by. Otherwise, we can say goodbye for 2 seconds and it's over. So let's try this. I'm going to press the green flag. What's on your mind? I want to feel better. So it's asking me, what do we mean if you got to feel better? I wish I were less lonely. Why would it be better if you were less lonely? I want to have somebody to love me. What do you mean you got somebody to love you? Well, I wish I were less lonely. Why would it be better? Then I could have friends. Tell me more. And so on. And once I'm done, I can say bye. The program tells me goodbye. Folks, this is an example of a simple chatbot that mimics empathy and sort of through this gives us the impression of some intelligence there. And the cool thing about this is really a sort of a programming language because the program really is in here. Now, The original Eliza program had a lot more rules, a lot more thesauruses, synonyms, more complex patterns. And so actually we could now teach this program to find more patterns and to have more variations and to have more words which to swap and to kind of more closely relate to us. This is a way how many chatbots used to be done, and pattern recognition and finding a context and substituting certain words against others still is how a lot of AI works today, even though today there are other models behind this. There are more statistical and stochastic methods with that, and those will be part of the next video. I'm going to show you how to do that in Snap. Here you have a framework to make dialogues, chatbots, and you can do that in Snap by modifying language to do a fuzzy pattern matching. Have fun. Cheers.